Okay, so this is the portfolio management portion of the Buck software. So in this case, we have two portfolios. Within the one portfolio, we have a hospital, a storage location, and a mall. So you'll see different types of buildings, and we'll go into the details in a second about the data that's entered. But for instance, here's the benchmarking. In this case, it's a combined benchmark. So again, it gives you the ability to look at the mall, which has a certain square footage, the warehouse, and then the hospital. Again, once we've uploaded the data, which you'll see in a second, it's going to calculate that energy intensity, electrical energy intensity usage, benchmark it to the type of facility it is. And again, we'll see that in the details, and then give you benchmark differences. So again, the idea here is if you enter 20 different buildings for a village or a city or some type of an agency, you can quickly see which of the buildings that really give you the most bang for your buck. And again, we show both by percentage and by actual kilo BTUs in this case, because it's a combined benchmark of electric and gas in this case. But it lets you figure out where, so just because something's a high percentage, if it's very small usage, then you may not want to spend as much time on a bigger building that has more savings, but maybe the percentage isn't quite as high. So that's the benchmarking. So let me go back and show you how we got to the benchmarking. So now if we come back and look at adding a building, so we'll look at the building that we've already added for the hotel or the hospital. So again, we're going to put in the square footage. We're going to put in the benchmark that's being used, in this case, Energy Star. The address, obviously state, city, and zip. And that's about it, other than the utility rate itself. So just with that data being added at a very high level, it's already going to select. It was mentioned before in the normalize that one of the default normalized values is the normalization of weather. So just by entering that data, it's going to select the nearest weather station and climate zone to do that normalization that was touched on before about NMEC. And then, like I said, the next important piece, and real quick, let me mention here, there's a number of inputs that most of the users that are just looking at performance won't see this level of detail. But just to make a general comment within the tool, this is our default tool, and there may be a number of things in here that really do not need to be visible for the I-REN program, but we decided to keep everything there as needed to begin with, and this will be Buck will be customized over time to make sure it meets the needs of the I-REN program. So there's things that we can take out if they're not really necessary. There's other things that we can add if they become necessary. So just to give you a heads up, so you'll see a lot of information on here. Some of it may not really be needed or need to be visualized for the users. And again, depending upon who the users are, we can fine tune that a little bit. But the other big piece is going to be what tariff, and you'll see that in a second. So we'll keep these updated based on the tariffs that are available. Same thing for gas, if this was a building with gas. And you'll see in a minute why that's important. So once we've uploaded the file, and again, this will be the energy engineer that'll be doing that. They'll have the historical file either in 15-minute, hourly, daily, or monthly. So for electric, it's likely to be 15-minute or hourly. They'll choose the file, they'll upload it. And once it's uploaded, then the consumption numbers will come up for electric, and if there is gas, will come up as well. So really those three pieces of entering basic building data, picking the tariff that's being used for that billing data, and uploading the data itself. So three fairly simple steps automatically is going to give you a whole bunch of information. So it's going to give you the benchmark information that we looked at before. And it's also going to give you, for that particular building, the analytics data. So we'll go into this. So first of all, we've got a data quality tab initially. So the first thing we want to know is how good is the data that we've uploaded from wherever the source is that it came from. So in this case, we're doing some data quality checks against Caltrack, which is a California CPUC standard for verifying data. So you can see, 0% missing data, 0% weather data, because again, this is what we're normalizing on for the electric. So this data is pretty good. So let's just go through the charts fairly quickly. So the first chart is a temperature versus kWh chart. So basically it's taking all of that hourly data and plotting it based on what the temperature and the kWh was at that data point. So for instance, we can look at just the weekdays, or we could look at just the weekends, or both. And in this case, it's a hospital, so the data is pretty consistent in this particular case. But it gives it the engineer the ability to look at data. Even kind of the novice can look for trends when they're there, and I'll point out a couple in the data that we do have. So this is a line chart, which again is looking at each of those hourly data entries over the course of the year from January to December, and looking at the consumption on an hourly basis. So basically you can see it's a little bit hotter here in the summer than in the winter. So this probably isn't as much of a desert situation as others may be. It also does some basic statistics on the data that came in. So again, setting upper and lower bands, picking the median. And then this is another one where the energy engineer can look for trends or look for things that might mean something. So for instance, back here, we had a number of situations where there was data missing. So that might be worth some investigation into the individual site to find out where there's some outages during these times. So for instance, you can zoom in and look at more details on the information. Or the other thing, whoops, sorry about that. Yeah, so basically it gives you the ability to look for trends and things within the charts itself. Another chart is the degree chart. So again, this will show the number of days where heating was required, number of days where cooling was required. So again, looking like it's a little bit more moderate temperatures than what the desert might be. And then a profiles chart. So again, all of this data is just coming in based on what we've seen. So for instance, in this chart, we're looking at 24 hours and then the kW usage. So you can look at different things like comparing winter to spring, winter to summer. You can look at specific months if you want to. So if you wanted to compare the winter months to the summer months, there's just things in there that you would expect to happen, and you can look at those. And same thing, you can look at weekdays. So it just gives the engineer the ability, and then again you can zoom in on different areas, zoom out, and look at different things. So it's again just things that are with very little bit of work, engineers can gather good data from. This is another one, the intensity chart, which is looking from January to the end of December, looking at midnight to midnight essentially, and looking for trends. In this case, again, it's a hospital, so the usage is a little bit more 24-hour-ish than say an office building. So if this was an office building, you would expect most of the energy to be used from 8 a.m. to 6 p.m. But you're also looking for times where here's some time where there was a lot of energy usage in a short period of time. It was a little bit different than the other data around it. Here's some areas where there really wasn't much energy usage at all, and this might relate back to what we saw before, where there actually might have been an issue with the data, or there might have actually been a shutdown in the plant during those times. So all things to make sure that the engineer is using as much information as they can to make those decisions. Then finally, the utility, the energy usage or utility or cost. So this is why it's important to bring the tariff into it. So at this point, we're going to be looking at the demand, both the demand KW and the energy. And again, we're breaking it down by month because we actually have hourly data. So then we can see when the on peak, mid peak, off peak, and critical peak, if there is any, times both from energy usage as well as energy cost. And then you see that as well. Other charges potentially can be included in there. So with that, that gives you a lot of good information. The next thing I wanted to go to is site parameters. So all of that other information, again, was pulled in with very little, very little data entry required or time required even. So this is if you want to go kind of to the next level. Still, it's fairly simplified modeling. And there's, as I mentioned, there's a whole section in the middle past this, it's detailed modeling. But this is fairly simplified modeling. So again, we've already told it's a hospital, 320,000 square feet. So we can add year of construction, number of floors above and below ground. We can add the schedule. Again, in this case, it's a hospital, so it's 24/7. We can ask some basic questions like, was there a recent lighting upgrade? Does it have occupancy sensors? We can pick some high-level HVAC and cooling type and heating types, which, as you can see, you can upload a picture of the building, say from Google Maps. So even if you haven't been to the building, an energy engineer can make some pretty good assumptions on what type of equipment. If they see a building, a big building with a cooling tower, they can assume that there's some kind of a chiller on it, etc. Again, when does the HVAC run? What are the cooling and heating set points? Again, a little bit tighter for hospital and maybe for a regular building. Again, does it have night setback, energy management system, economizers, some real basic questions and some additional details that can be brought in. For instance, if it's a hospital or an office, if you know it, you can add it. If you don't know it, that's fine too. On the resiliency side, does it participate in DR? Does it have battery storage, thermal energy storage, self-generation? Just some basic questions. And the purpose for those is going to be the next page, which is the initial measures list. So this is just some simple things that it generates based on the information it's been provided and some logic that we have in the background that can say, okay, here's some for that building as we've defined it and the data that goes along with it. Here's a handful of measures that might be good candidates for the building. So we said it didn't have occupancy sensors before, so that might be a good one. And then all of this ultimately will go into a report that we'll work with tech and the I-REN team that can be provided to you. And all of this just has default existing conditions, default terminology for energy savings, default information for what the calculations are, which can also be modified as required by the engineer or changed to go into the report. So again, so we'll say installing occupancy sensors makes sense, and we'll say fixing the economizer because we know the economizer is really stuck. It's not really moving the way it's supposed to be. So let's use those two. And at that point, it's going to do the initial population of what's called the opportunity register. So at this point, those two items that were picked up by the methodology of the analytics are added. So all of the information that we saw there, add fixed economizer, install occupancy sensors, the description, some potential, etc. And things that will be used also when we get into the M&V or the verification part. This is where data can be entered as well. And the idea here is that you can select the ones that you want to use and decide if you want them to be in a report or not, or they can just be informational. And you can decide, okay, I understand that, but now I've been to the building and I really know what it needs. So I've identified a couple of other opportunities that are probably better for that building. So it gives you to be able to put in a custom opportunity. So it is going to ask some for basic things like what systems it associated, what's the area that it's served, what status is it from the process point of view, implementation date, And it'll ask how was it estimated. It'll ask how it was verified. Again, the descriptions can be put in, the values can be put in. And when all that is done, it will look exactly like one of these, except it'll indicate that it was custom. It didn't come in from the analytics. So that way it gives the energy engineer full flexibility to cover what will actually be used. And then when all of that data has been entered, we'll come back to the dashboard again, and those items will be included in here. And then again, once we get into the M&V phase, we'll also see, refresh that. Once we get into the M&V phase, we'll see the percentages. And then once again, if we look at the charts above, if we decide to take the hospital out, or if we decide to put, let's take the other portfolio out and only use the hospital, then we can see that the savings goal was 210 kWh, realized 145, goal of 69. You see that up there, same thing for GHG. And that way it gives the user at the dashboard level the ability to just look at the data that they want. If they really do want to look at what the total portfolio looks like, they can put these buildings back in. It's going to bring the realized savings down because those are not yet into the M&V phase.